So in normality, we came to know about how to calculate equivalent weight and valence factor, and then calculate equivalent mass of following, in which I have explained about this. Do you know how this value comes? X is equal to 3, X is equal to 2, or X is equal to 1. Any explanation from both of you? Rim and Samia?
No, sir.
See, I told you that this so basically this is acid. These all are acid, and since X is equal to number of ions, and if X is equal to here 3, that means it is giving 3H plus, and this is giving 2H plus, and this is giving 1H plus. Now, how this value come? How it gives 3H plus and H3PO3 only 2H plus, and H3PO2 only 1H plus. So see, I'm going to explain it with the help of the structure of the H3PO4, H3PO3, H3PO2. H3PO4 has a structure P double bond O, OH, and then O, OH, and then O, OH. Again, H3PO3 have a structure H3PO3, and H3PO2 has a structure that is like this. Now see, if you are going to dissolve this in water, in all this in water, water is a polar solvent, and see what happens. Oxygen is the second most electronegative element. So oxygen is highly electronegative than hydrogen. That's why hydrogen's electron will be attracted towards oxygen, and that's why on oxygen there will be delta negative and here delta negative, delta positive, and again here you can see delta positive, delta negative, and delta positive, delta negative, delta positive. Come to the first one, this one. These 3 bonds, all the 3 bonds are polar. So whenever you are dissolving it in water, it will be easily breakable, and it will break, and it will give 3H plus. Whereas when we talk about H3PO2, these bonds will be easily breakable and dissociated and broken down into H plus, and it will give 2H plus. Now this H is not ionized and gives H plus. Why? Because phosphorus and hydrogen, the electronegativity difference between phosphorus and hydrogen is not much larger. That's why it is not much polar, and that's why it is not breakable, and it is not dissociated into ions. In the same way, you can understand that there will be delta negative, delta positive, and this will be dissociated into H plus, and it will give only one H plus, whereas this H and this H will not be dissociated because these bonds are not that much polar. Is that clear, everyone?
Yes,
Rim?
sir. Yes.
Okay, please write it. Rim. Okay. What you just said, Samia? I'm not audible.
No, sir, I said I did not understand.
Okay, you didn't get it. See, Samia, do you know what is electronegativity? Electronegativity is the property of any element which withdraw the bonded pair of electron. So you know that there is 2 electrons between oxygen and hydrogen because it has only one bond. So oxygen phone, always remember phone. This is the first most electronegative element. This is the second most electronegative element. This is the third most electronegative element. Oxygen is very highly electronegative than hydrogen. That's why hydrogen's electron will be attracted towards oxygen, and it will have delta negative charge and delta positive charge. And whenever there will be charge, that is polar molecule. So it is when it will be polar molecule and you are going to dissolve it in water, which is already a polar solvent, it will be dissociated. So this will be dissociated in the same way this and this will also be dissociated, and it will give H plus H plus H plus. This bond will be broken, and here it will be -1 -1 and 3H plus will be given. In the same way, these two H plus, these two hydrogen will give H plus 2H plus, and this bond will not be broken because there is not much electronegativity difference. This bond is not much polar. Is that clear, Samia?
Yes, sir.
Okay, please write the structure and then we will move to the next number of gram equivalent.
Sir, can you scroll a little bit up?
Like this.
Yes.
Okay. Let me know when you are done.
Done, sir.
Okay, Samia, are you also done? Rima, are you done with the structure? I will give you
Yeah, sir.
some rules
Yeah.
how to draw structure. Okay, thank you. Samia.
Yes, sir.
Okay. So I already told you, for studying normality or understanding normality, there will be two terms first we have to know. The first one is equivalent mass or weight, and the second term is number of grams. So mass is basically till this. Now we are going to of gram equivalent, moles or number of moles, just like that, number of gram equivalent, and it has a formula on equivalent mass, given mass upon equivalent mass. The given mass will be given in the question, and equivalent mass you can easily calculate it. So I just have given you the formula, and now I'm going to give you a question. Just apply the formula. You know how to calculate equivalent mass, and you will get your answer. 49 gram of H2SO4. Calculate gram, GM for gram, equivalent, EQV for equivalent mass. Can you do this question, Rim, Samia, and
Yes, sir.
Madiha?
Yes.
Very good. Try. Try it. Madiha, is this your first class?
Yes, sir.
Okay. Have you studied normality before this?
No, sir.
Mole fraction.
Yeah, we did mole fraction.
Okay. You did mole fraction. Okay. So this is the basically uh, in between of normality. Then we will start a new topic soon. That is solubility. You will get to understand from there. And before this, I will talk to sir to take an extra class for
So is it 1?
one. Samia, Rim, your answer. See, we need
Sir,
to
I also got
calculate.
one.
So, see, we need to do calculate gram equivalent mass, which has a formula. Given mass, and given mass is given, that is 49 gram upon equivalent mass. How to calculate equivalent mass? Equivalent mass of H2SO4. That has a formula, molar mass upon X. Now, molar mass of H2SO4, you can easily calculate 98 it will be. And X is very important. If it is acid, just see how many number of H plus it is giving, how many H plus it is giving. And if it is base, then see how many OH minus it is giving. And if it is salt, then see either positive charge or negative charge. That is the value of X. So you can see H2SO4 will give 2H plus, so it will be divided by 2, and the value of equivalent mass is 49. So just put the value and you will get 1 gram equivalent. The unit is 1 gram equivalent. Okay, Samya, Rim, and Madiha.
Yes, sir.
Okay. So moving to the next part, that is normality. That is normality. Normality is denoted by N. First of all, I am going to define it. It is basically number of gram equivalent per unit volume of solution in liter. Number of gram equivalent per unit volume of solution in liter. If you are going to express it in mathematical formula, normality will be equal to number of gram equivalent upon volume of solution in liter. Volume of solution in liter. So if you are going to talk about its unit in numerator, it will be gram equivalent upon volume of solution, that is per liter. This is the unit of normality, or we also use directly N. Like if you have 2 gram equivalent per liter, or you can directly use 2N, that represents 2 gram equivalent per liter. Also, there is, please correct it, the definition, number of gram equivalent of solute. Number of gram equivalent of solute. Like in molarity, number of moles of solute per unit volume of solution in liter. It is just like that. Gram normality is number of gram equivalent of solute per unit volume of solution. So here you can also write number of gram equivalent of solute upon volume of solution in liter. Please write it and let me know. I'm going to give you a question. 4.9% weight by volume H2SO4. Calculate normality.
Sir, that N stands for normality.
Yes, N stands for normality.
Okay.
Can you do it, Madiha?
Yes, sir.
Okay, please try it and let me know if there is any answer from any of you.
Sir, is the answer 1.
Answer is 1. Okay, very good. Who is this? Rim.
Cream. Yeah.
Okay. Samya, any answer from you?
Sir, I got 10.
Okay, just see, can see 4.9% weight by volume H2SO4. What does this mean? This is very important to note that this means 4.9 gram of solute, that is 4.9 gram of solute, that is H2SO4 in 100 ml solution. In 100 ml solution. Also, what it is asked to calculate normality, which has a formula, number of gram equivalent upon volume of solution in liter. Now the volume of solution is given and we can easily convert it into liter. But the problem is that how to calculate number of gram equivalent. So number of gram equivalent is also has a formula. Number of gram equivalent has also formula is equal to given mass upon equivalent mass. Given mass upon equivalent mass. Given mass is given 0.9. You can see 4.9 gram of H2SO4 upon equivalent mass. We just calculated equivalent mass of H2SO4, that is molar mass, 98 upon, it will give 2H plus because H2SO4 has 2H. So it will have a value 49. Now just put the value 49 and remove the decimal and you have to multiply it by 10 in denominator and you will get 1 by 10 gram equivalent. So I'm going to just put the value. The number of gram equivalent has a value 1 by 10. Volume of solution is 100 ml. And to convert it into liter, we have to divide it by 1000. So it will be 1 by 10 into 1000 divided by 100. Also, you can see it will be all cancelled and the value of normality will be 1 gram per 1 gram equivalent 1 gram equivalent per liter. Is everyone okay with this? Very good. Samya, what was your mistake?
Sir, calculation.
Okay. Nadia, got it?
Yes, sir.
Okay. Can I change the slide?
Yes, sir.
1 second, sir.
Okay. Take your time and let me know when you are finished. Everyone done with this?
Yes, sir.
Okay, Madhya, you are also done with this?
Yes, sir.
Okay. Moving to the next question. Calcium carbonate is present in a decinormal solution of volume 500 ml. Find the mass of CaCO3 present in solids. Please do it.
Sir, what is decinormal?
Decinormal. See, First of all, I'm going to tell you here only Desi normal. That is the value of normality given. Desi normal has a value 1 by 10. After this question, I will give you a lot of, I'll give you a list of how to tackle this type of question. If Desi normal, centi normal, binormal, that is very easy, or semi normal, how we are going to calculate.
Okay, sir.
Desi normal, that means 1 by 10 gram equivalent per liter. That means 1 by 10 in is given.
Sir, can you explain?
Okay, just see. CaCO3 is present in a Desi normal solution of volume 500 ml. See, Desi normal, that means normality is given as 1 by 10 and volume of solution is 500 ml. What we need to calculate is find the mass of CaCO3, but just don't go directly on this. Go step by step. Normality has number of gram solution in liter, and this normality of basically number of gram equivalent is of solute. Now see, you can easily now why it is 1 by 10 number of gram equivalent. I am taking it as x volume of solution in liter, that is 500 upon 1000. We have to convert it into liter, and it will be 1 by 2. So I'm going to solve it 1 by 10, and this 2 will come to in numerator, and it will be 2x, and x, that means number of gram equivalent is equal to, we got a value 1 by 20. Is everyone okay with this?
Yes, sir.
This is basically gram equivalent. This is the unit. Now, number of gram equivalent has a formula. Wait a minute. Number of gram equivalent has a formula, that is given mass upon equivalent mass, and we need to calculate given mass, that is m. And what about equivalent mass? Equivalent mass we can easily calculate, that is molar mass upon x, and equivalent mass of CaCO3 we need to calculate. Molar mass of CaCO3 is 100, and what about x? CaCO3, whenever you are going to dissociate it, it will give Ca plus 2 or CO3 minus 2. So I told you that whenever this type of compound will come, X, you have to take either positive charge or negative charge, because both the charges are equal, here plus 2 or minus 2. So you are going to take without sign, X is equal to 2. So equivalent mass has a value which is 50. So I'm going to just put the value 50. Now number of gram equivalent has a value 1 by 20 is equal to m upon 50. M upon 50. Again, you can calculate m will be equal to 50 upon 20. 0 will be cancelled, and it is 5 by 2. That means 2.5 gram. Got it or not?
Yes, sir.
Rim,
Yes, sir.
Madiha.
Yes, sir.
Okay. Should I need to slide it up?
Yes.
Okay. So please do it and let me know. Then here our concentration terms is completed. Done, everyone?
Yes, sir.
Yes, sir.
Very good. Please do it. Let me know when you are done.
Done, sir.
Samia and Madiha.
Done, sir.
Then,
Very good. Now we are going to talk about a new topic, which is very important. This all concentration terms are from class 11th, but now we are going to talk about solubility. Solubility. That is a fresh topic for class 12th. See, what is solubility? Whenever in a fixed amount of solvent, or you can take water, the maximum amount of solute, you can take salt or sugar to understand in a better way, the maximum amount of solute that will be dissolvable or soluble in that solvent is called solubility. So I'm going to define it first. The maximum amount of solute dissolved in a specified amount of solvent at constant temperature, at constant temperature is called solubility. So solubility can be expressed in different parameters like gram per liter or kg per liter. But in Henry's law, it is defined in terms of mole fraction. So we will talk about it when I will start teaching Henry's law. Solubility can also be defined in terms of mole fraction. So this is solubility in a specified amount of solvent. Maximum amount of solute that are soluble is called solubility. The first topic after this is on which factor solubility depends. So I'm going to write a topic. Write with me. Factors on which solubility depends. Solubility depends. So there are three factors on which solubility depends. The first is nature of solute and solvent. Nature of solute and solvent, and how does it depend? So see, how does it depends? Nature of solute and solvent. Always remember the solubility principle. You can call it solubility principle. What does it say? This says like dissolves like dissolves like. That means, do you know what is polar and what is non-polar? Anyone? What is polar and what is non-polar? Rim, Samia, and Madiha. Am I audible to all of you?
Yes, sir.
Do you know what is polar and what is non-polar?
No.
See, polar means charged, and non-polar means uncharged. So I'm going to write a very small point here. Polar solute dissolves in polar solvent. Polar solute dissolves in polar solvent. Like NaCl dissolves in H2O. You know that NaCl has a charge that is plus and that is Cl has minus. When it comes to H2O, you know oxygen is highly electronegative than a hydrogen, so it will have delta negative, delta positive, delta negative, delta positive. So basically you can see this is polar solvent charge and this is polar solute. So solubility principle is like dissolves like. That means polar solute will be dissolvable or soluble in polar solvent, and non-polar solute is dissolvable or soluble in non-polar solvent. Non-polar, that means uncharged molecule. Everyone okay with this?
Yes, sir.
Yes, sir.
Okay. Have you written the definition of solubility, Madiha?
Yes, sir.
Okay. So the next point is that non-polar solute dissolves in non-polar solvent. And also see, this is CCl4, which is non-polar, will be dissolvable in benzene, that is C6H6. These are non-polar. So solubility principle is simple. Like dissolves like, that is depends upon the nature of solute. If solute is polar, that means it will be soluble in polar solvent. This is how it depends on the nature of solute and nature of solvent. Please write it. And if you have any doubt still, just ask me. Then we will I will explain the next factor on which solubility. Everyone done with this?
Yes, sir.
Yes, sir.
Very good. Madhiya, are you also done with this?
Yes, sir.
Now see, the next factor is effect of temperature. How does it affect solubility? So first of all, we have to see if the solution you are making is exothermic or endothermic. So I'm going to process is exothermic, then with increase in temperature, and if dissolution processes, then with increase in temperature. Just see, I'm going to explain the this one last, this one first. What is endothermic? Endothermic, that means heat is required for this process. You need to give heat to the system or the process or the reaction, then it will go on. Are you getting my point, Rim and Samia and Madhiya?
Yes, sir.
Yes, sir.
And
Yes, sir.
exothermic is a process in which heat is giving out. Heat is giving out. So you can see heat is required for this endothermic. Heat is required for this dissolution, for making a solution. Heat is increase the temperature for endothermic process. And in terms of, if you are going to increase the temperature, heat will increase or decrease. Heat will increase or decrease. Any answer?
Sir, can you repeat the question?
If you are going to increase the temperature, heat will increase or decrease.
Increase.
Increase. It's obvious that you have processes carried out. Initially it is 5 degrees centigrade, and you are going to make it 25 degrees centigrade. So for the that process, heat temperature increase, that means you have given heat. Yes or no, Samia, Madiha?
Yes, sir.
So you can see endothermic process in which heat is required, and you are, if you are going to increase the temperature, that means it is favorable condition for that process. So in endothermic process, whenever you are going to increase the process, increase the temperature, solubility increases. Solubility increases. And whereas when we talk about dissolution process, is if the dissolution process is exothermic, that means it is giving out the heat. It doesn't require heat. It has lots of heat energy. That's why it is giving out. And at that time, if you are going to increase the temperature, that means indirectly you are going to give heat to the system or the process, which is in favorable condition for that process. That's why in exothermic process, when temperature is increased, the solubility decreases. Just think about it. Exothermic process, that means heat is giving out the system. And if you are going to increase the temperature, solubility decreases. So it will be inverse. If you are going to decrease the temperature in exothermic process, solubility increases. But in endothermic, that you are cooling it, that means solubility decreases. Please write it and think about it. And if you have any doubt regarding this, please ask me. Please let me know when you are done with this.
Done, sir.
Done, sir.
Done, sir.
So do you have any doubt regarding this exothermic process? That means it is giving out. If you are going to increase the temperature, solubility decreases. But in case if you are going to decrease the temperature, solubility increases. In endothermic process, heat is required.
No, sir.
Increasing temperature, decrease the temperature, solubility decreases. Okay. Everyone done with this?
Yes.
Okay. Now, the third factor is basically pressure. Before this, I have a question. For aquatic animals, it is they are not comfortable in summer or hot water than in cold or winter. Are you getting my point? In summer, the aquatic animals are facing some problems in living in water as compared to in winter. In winter, they are comfortably live in water. Rim, Samia, have you understood the question?
Yes, sir.
Yes, sir.
Okay. Okay, just see. So I'm going to answer this question. Dissolution of gas in liquid is an exothermic process. That means oxygen dissolving in water is an exothermic process. And in summer or hot water, the temperature is high. When temperature is high, solubility of gas in liquid will be lower or not?
Yes.
As temperature increases, solubility. So aquatic animals are more comfortable in cold water. So please write it and write the third factor, effect of pressure. Please let me know when you are done with this.
Done, sir.
Samia and Madiha.
1 second, sir.
Done, sir.
Okay.
Done, sir.
Okay. So see effect of pressure. So generally pressure does not affect on solid because solid are already compressed. So pressure does not affect on solid. Pressure affect on liquid. Liquid are already compressed. So pressure does not affect on solid. Liquid are already compressed. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on solid. So pressure affect on liquid. So pressure affect on sol solid into liquid. Talk about gas. Gas will have some effect. Sorry, pressure will have some effect when gas will be dissolved in liquid. That we will study in Henry's law. So first of all, I'm going to write something about effect of pressure. Write with me. There is no effect on solubility. There is no effect on solubility of solid in liquid, of solid in liquid, because solids are compressed. So there is no effect of solid in liquid. But when we talk about gas, solubility of gases in liquid, solubility of gases in liquid, it depends upon the nature of gas. It depends upon the nature of gas. As for example, NH3 and HCl are highly soluble in water than O2, N2 and helium. Why does it so? Because NH3 and HCl will form some hydrogen bonding in water. That's why it is highly soluble in water as compared to O2, N2 and He. So please write it. It depends upon the nature of gas.
Done, sir.
Done, everyone?
Yes, sir.
Yes, sir.
Very good. Now we are going to talk about Henry's law. What does Henry says? Henry's law. So first of all, I'm going to define it and write with me, then I will explain. According to this law, solubility of gas in liquid is directly proportional to partial pressure of that gas above liquid surface. Please write it and let me know when you are done with this. It is very easy to understand what Henry's law says with the help of an example, cold drink, bottle of cold drink. Are you done with this? Everyone?
Yes, sir.
Okay.
Yes, sir.
Madiha.
Yes, sir.
So see, here is a bottle of cold drink. My drawing is very, very worst. Now see, you have seen cold drink or fillet that this is all liquid, but from here to there, gas is present. Yes or no? Whenever uh, we open the bottle, we hear some noise that represents there is gas. That pressurize or exert pressure on this liquid. Are you getting my point?
Yes, sir.
So we can take this example because there is gas that is soluble, gas that has that is exerting some pressure on the liquid surface. So according to Henry's law, I'm going to write it in mathematical equation. According to this, solubility of gas directly proportional to partial pressure of gas above liquid surface. Above liquid surface. I can also write, if this is directly proportional to that, I can also write partial pressure of gas above liquid surface directly proportional to solubility of gas. Can I write it?
Yes.
Now see, I told you that solubility defined by Henry's in terms of mole fraction. In terms of, he defined solubility in terms of mole fraction or solubility expressed in terms of mole fraction. So I am going to take it as zeta or x. It is represented by partial pressure of gas. This gas that is exerting pressure on the cold drink, partial pressure is directly proportional to mole fraction of that gas. We are not talking about the mole fraction of liquid. There is two component. One is liquid and another is gas. And we are talking about only gas. Partial pressure of gas directly proportional to the mole fraction of gas. And to remove this proportionality sign, we have a constant that is known as Kh, and Kh is stand for Henry's constant. What does it stand for? Henry's constant, which depends on solvent. Wait a minute, just don't write it. Henry's constant. So please write it and let me know. Depends on temperature, right? Depends on temperature. Are you done with this?
Yes, sir.
Very good.
Yes, sir.
Now see, we got H into, we have a graph. If we are going to plot a graph between partial pressure versus mole fraction, that is mole fraction of gas in liquid, since we know that this is directly proportional to this, so the graph will be a straight line. Now another important point is that when we talk about slope that means tan theta. Just consider theta here. So tan theta will have a value perpendicular upon base. And what is perpendicular? What is perpendicular is basically partial pressure, and base is basically mole fraction. And come to this formula and find the value of kh. Kh is equal to partial pressure of x or not, partial pressure of gas above liquid surface upon mole fraction of gas in liquid. So basically we can also write kh here. That means slope of partial pressure versus mole fraction of gas is constant. Process it in your mind, and if you still have, if you still didn't get, don't get it, please let me know. Slope, that means tan theta, also denoted as an perpendicular upon base. What is perpendicular? That is partial pressure. It will be in partial pressure. And what is base? Base is in mole fraction. And from this formula, you can see kh has a value partial pressure upon mole fraction. Again, with the help of slope, we got partial pressure upon mole fraction. That is the value of kh. That means the slope of partial pressure versus mole fraction of gas and liquid gives Henry's constant. Is that clear, everyone?
So can you repeat?
Yes, Samia, see. From this formula, what is the value of kh? Kh will be P upon X, partial pressure upon mole fraction. Yes or no?
Yes.
And do you know what is slope? Slope is basically tan theta.
Yes.
You know about it or not? Perpendicular upon base. So for this tan theta or any tan theta perpendicular, that means the value of partial pressure upon base, what value of mole fraction. So tan theta is equal to perpendicular upon base, partial pressure upon x, mole fraction. That will be equal to kh, because kh is equal to p by x. Samia, Rem, Madiha.
Got it.
Very good. In class 11th, in physics, you have studied about it like this. Slope of displacement time graph gives velocity. In the same way, slope of partial constant. It is not to be remembered. It is, the concept should be understood. Are you done?
Yes, sir.
Yes, sir.
Very good. Now I'm going to give question on this base. Very easy question. If N2 gas is bubbled through kilobar. Please try it.
So in this question, you have to find the moles of N2.
Can you solve it, or I should explain?
Sir, can you explain?
Okay. So see, it is very simple question, but the first time you are saying maybe that means the solution component is gas, that is N2, and water at 293 Kelvin. It asked about how many moles of N2 gas would dissolve in 1 liter of water. We need to calculate moles of N2 in 1 liter of water. Also, it is given that partial pressure is this much and Henry's constant is this much. So since so P is equal to KH upon X mole fraction, yes or no? Tell me.
Yes,
This will be the
sir.
formula.
Yes, sir.
Now see, partial pressure is already given, that is 0.987, and KH is already given 76.848 kilobar. So I can easily convert it into bar. It will be this much bar or not. Multiplying it by 1000, it will be converted into bar. 76.48 kilobar will be equal to 76480 bar. Samia rim 76.48 kilobar will be equal to this much bar or not?
Yes,
Yes.
So I'm going to put the value 76480 into mole fraction of gas in liquid. What does this mole fraction say? This is the mole fraction of N2, because in Henry's law, mole fraction we calculate or put is the it is mole fraction of gas. So just convert it. Mole fraction of gas will be equal to 0.987 upon 76480. Can anyone solve it? Please speak up. Samia, Rem, Madiha. Rem,
So
am I audible?
this is the final answer.
No, not the final answer. I calculated more. Is clear till this?
Yes, sir.
Now see, for the formula of mole fraction of N2 will be equal to number of moles of N2 upon number of moles of N2 plus number of moles of water, because two components are present, yes or no?
Yes, sir.
Okay. Now see, this is the value we have already calculated. Now we need to calculate this value. What about this? It is giving the hint. Volume is 1 liter. Volume of water is 1 liter. And we know the density of water from childhood, that is 1 gram per ml. So we can easily calculate mass. Density is equal to mass upon volume, and mass is equal to density into volume. Density is 1 gram per ml into volume, that is 1 liter is equal to 1000 ml. So just convert it into 1000 so that it will be easy to see. So the mass of water is 1000 gram. Mass of water is 1000 gram. And now we can easily calculate the number of moles of H2O, that is given mass 1000 upon molar mass of water, that is 18, will be equal to 55.5 moles. Now see, this has a value 1.29 into 10 raised to the power minus 5. This number of moles of N2 upon number of moles of N2 plus this has a value 55.5 moles. Again, see, in Henry's law, you know, you have seen that it is 1 liter of cold drink, 1 liter of cold drink, and only very little gases are present, that is exerting pressure. Are you getting my point? In comparison to the amount of liquid, the amount of gas is very, very small. That's why in denominator, we are going to neglect it. In Henry's law or Henry's equation, you have to neglect in denominator, because if you are going to add 55.5 plus 0.00 something, it won't affect the value 55.5. It will be almost equals to this. That's why I just neglect it. Now number of moles of N2 will be equal to 1.29 into 10 raised to the power minus 5 into 55.5. Samia, Rim, the and let me
Audible.
uh-huh. Rim, what were you saying?
That you weren't audible.
Okay, please write it and then I will explain again. Madiha, Samia,
Done, sir.
done. Samia, and if you have any doubt, Samia, you were not audible. Okay. Do you need another again the explanation? Rim,
No, sir.
Rim.
No, sir.
Okay. So this is basically
Sir?
Samia, Rim. Am I audible to all of you?
Yes, sir.
Okay. So I'm going to give you some questions from NCERT. Home assignment. In text question 2.6. Question number 2.6 and 2.7. Also, this is unsolved question. Also, 2.1, 2.2, 2.3, 2.4, 2.5. That means 2.1 to 2.7. You all have to do this question from in the next class. Please make a PDF and send it to please send it.
Sir, where should I send?
Send it to, I'll check it. Send it
So your voice is breaking.
this number. I'm being audible. Now am I audible?
Yes, sir.
Okay. And also from exercise 2.4, 2.5, 2.6, 2.7, 2. 2. 10, 11, 13. Okay. This question also should be solved, and please send it directly to me in PDF form. Okay, everyone. Please check your chat box. Everyone done with this?
Yes, sir.
Okay. Okay. Is there any doubt in the previous class or this class?
No, sir.
No, sir.
Okay. Okay, then see you in the next class on Monday. And please do this homework. It is very important. First of all, I will discuss this question and move to the next topic, that is vapor pressure. That will be related to Rawls law, ideal solution, non-ideal solution. So if you will do this on time, it will be very easy for us to move ahead with the same speed. Okay. And if you have any doubt, or Madhya, you have any doubt in concentration term, then we will have definitely an extra class. Okay, for concentration term.
Thank you, sir.
Okay, everyone. Thank you. Thank you. You may go.
Thank you, sir.
Thank you. Madhya, do you have doubt